You shower every morning. You shave, wax, or trim things that grow in places that seem to make no sense. And at some point, most people ask the same question without ever getting a real answer. Why is the hair even there? Not on your head. That one is obvious. But the armpit hair, the pubic hair, the eyebrows, the eyelashes, the beard that grows on half of all human faces, but not the other half. The fine invisible layer that covers almost every square inch of your skin. Why does any of that exist, and why is it distributed the way it is? Dense in some places, invisible in others, with no apparent logic to the pattern. The answer is one of the stranger stories in evolutionary biology. And it starts not with why humans have hair, but with why humans lost almost all of it. Every other primate on Earth is covered in thick body hair. Chimpanzees, gorillas, orangutans. Our closest living relatives are essentially fur-covered. Humans are the naked ape, nearly hairless from the neck down compared to every other member of our evolutionary family. And this is deeply strange, because hair is one of the defining features of being a mammal at all. It insulates, it protects, it senses. Losing it was not a small thing. It required evolutionary pressure strong enough to overcome hundreds of millions of years of mammalian tradition. The leading explanation comes down to heat and hunting. Around 2 million years ago, early humans began moving out of forests and into open African savanna. This changed everything about survival, because the savanna hunts differently. You cannot surprise a zebra in open grassland the way you can ambush prey in dense forest. What early humans could do, what no other predator could do, was run. Not fast, but for a very long time. Persistence hunting, tracking an animal at a steady jog for hours, in midday heat, until the prey overheats and collapses. This works because humans can sweat and cool themselves while moving continuously. Most four-legged mammals cannot do both at once efficiently. A running cheetah overheats within minutes and must stop. A running human can keep going. But this advantage only works if the heat generated by all that running can actually escape the body. Dense body fur traps heat. It is an excellent insulator, useful at night, in shade, in cooler climates. Under a midday equatorial sun, while jogging for hours, it becomes a death sentence. So the fur went. Over hundreds of thousands of years, natural selection favored individuals who ran cooler, who had finer, shorter, sparser body hair that allowed sweat to evaporate directly off the skin rather than being trapped beneath a coat. The sweating system expanded simultaneously. Humans have far more sweat glands per square inch than any other primate, an extraordinary cooling system that only works on relatively bare skin. By roughly 1.2 million years ago, genetic evidence suggests the human lineage had already made the shift to essentially naked skin. We became the only primate that had to invent clothing to survive in cold climates, because we'd traded our biological insulation for a running advantage that let us eat. But here is where the story gets interesting, because evolution didn't take all the hair. It kept specific patches in specific places, and the reasons for each one are different. Start with the head. Scalp hair keeps our brains from overheating and lessens water loss from the top of the head. When you're standing upright in equatorial sun, the top of your skull takes the most direct solar radiation. Tightly curled scalp hair is more effective at reducing heat gain than other hair types. It creates a layer of insulating airspace that blocks solar radiation while still allowing air circulation. This is why the earliest human ancestors almost certainly had tightly coiled scalp hair. The variation in hair texture you see across human populations today reflects adaptations to different climates that developed after humans spread out of Africa. Then there are the eyebrows and eyelashes. These are among the most clearly functional patches of hair on the human body. Eyebrows redirect sweat and rain away from the eyes, a critical function for a species that sweats heavily and needs to see clearly while running. They also became, over evolutionary time, one of the most expressive features of the human face, capable of communicating emotional states with extraordinary precision at a distance. In a species as socially complex as ours, where reading other people's intentions accurately could determine survival, eyebrows may have been retained and amplified, partly for communication. Eyelashes serve a more straightforward mechanical function. They detect airborne particles before they reach the eye surface, triggering a blink response. Now for the patches that confuse people most. Armpits and pubic areas. Hair in the armpits and groin was likely kept because hair in those places is an excellent means of propagating human pheromones. The apocrine glands, the glands that produce the chemical signals associated with body scent, are concentrated most heavily in exactly these two locations. The hair acts as a surface area amplifier, trapping and slowly releasing these chemical signals into the surrounding air. In an ancestral environment without deodorant, without clothing, and with close physical contact between group members, these scent signals carried real information: reproductive status, genetic compatibility, health, stress levels. The hair in these locations was not random. It was a broadcasting system. This also explains why pubic and armpit hair develop specifically at puberty, the same time the apocrine glands become fully active. The hair and the glands come online together as a single coordinated system, precisely when reproductive signaling becomes evolutionarily relevant. Facial hair tells a separate story, and it is specifically male for reasons that have nothing to do with warmth or scent. Among our closest relatives, the African apes, facial hair is equally prominent in males and females. Relative to the African apes, human females have significantly reduced facial hair, whereas at puberty, human males develop continuously growing hair covering the jaw and neck. Research on beard perception consistently shows that men with full beards are rated as appearing more dominant, more aggressive, and higher in social status. One hypothesis, tested with actual physical impact experiments, suggests that the beard may have evolved partly as a protective padding for the jaw during physical confrontation, absorbing some of the force of blows to the face. Whether or not that specific hypothesis holds up fully, the evidence that beards function as a dominance and status signal is consistent across multiple studies. And then there is the fine, nearly invisible layer of vellus hair that still covers essentially every part of the human body. This is the evolutionary remnant of the full coat. Far too fine to provide meaningful insulation, but still serving one important function: sensory detection. Each fine hair follicle is surrounded by nerve endings. When that hair moves, from a breeze, from a crawling insect, from a light touch, those nerve endings fire. This is why you can feel a mosquito landing on your arm before it bites. You are detecting the disturbance in your hair field, not the contact on your skin. That early warning system was worth keeping even after the insulating function was gone. So here is what the pattern actually looks like when you understand the logic behind it. Humans lost body hair to become endurance hunters in equatorial heat. They kept scalp hair to protect the brain from solar radiation. They kept eyebrows to redirect sweat and communicate emotion. They kept eyelashes to protect the eyes. They kept armpit and pubic hair to broadcast chemical signals at reproductive maturity. They kept beard growth in males as a dominance display. And they kept a fine residual layer everywhere else as a sensory detection system. None of it is random. None of it is vestigial in the sense of being left over without function. Every patch of hair on your body is the result of a specific evolutionary pressure that operated over millions of years, solving a specific problem your ancestors faced. You look the way you look because the way you look worked. Every time, in every generation, for longer than the human species has had a name for itself.